we have started in the previous session to learn multimodal deep learning techniques, wherein how are we dealing with the data from various types of modalities. Here we will be talking about the data set which is helping us to train the model. As I mentioned in the previous session, we are using the MS COCO data set for image captioning, which will help us to train the model because this is a huge data set, right. I will just give a few statistics about the data set, then we will see how the image captioning is done using this data set. So, this session is all about the intricacies of the data set. What are the key features of this data set? This data set consists of approximately 3,30,000 images with more than 2 lakh labeled images, and these images cover a wide variety of scenes, objects and activities of real world. Then captions, for every image that is existing in this data set, 5 types of captions have been given depending on the relevance to the features. And how many types of categories of objects are used here? Various types of objects are covered here, approximately 80 object categories, and multiple complex scenes such as people, animal, vehicle, everyday items and so on. And the data set also includes annotated object segments and what are the key points of each image, which will help in working with image feature extraction. Then how the data set is split? The data set is divided into, the training set is 1,18,000 images, validation set is 5,000 images, test set is 5,000 images, and for every image we are getting the additional annotations. These annotations, like beside the captions, the data set is containing annotations for object segmentation, what are the key points of the images, what are the dense captions, etc., which will help in dealing with the computer vision and NLP tasks. What are we working under computer vision? We are trying to understand the features of the image. What are we doing under NLP tasks? We are generating the relevant caption for the image. And what are the applications of this data set in image captioning? We are using this data set to train the model. We are also using the data set in order to evaluate the built model, right? What is image processing with convolutional neural networks? We know whenever we are going with smaller data sets in tabular form, we go for machine learning models. Whenever we are working with image data, we might use CNN, right? And the data size is increasing. So, how are we working with the CNNs? These CNNs form the backbone for image processing tasks, especially when you are trying to work with image captioning. They are very good when you want to recognize the spatial hierarchies of the image. Spatial hierarchy deals with which image is positioned in what place. Sometimes, say for example, you are trying to overlap one image on the other. When you are overlapping, who is seen first? Both the images are seen. One part of this receiver, one part of this slide changer, right? You are going to see both the images, but who is in the forefront and who is in the background? That is the spatial information. So, it helps us to identify the spatial informations, the hierarchies of the images, etc., which will help us to recognize the objects, understand the scene and extract the features. How the CNNs are working, just a brief of it. This you might have learned under deep learning for vision systems. Just a quick look at the basic features of CNN. It has convolutional layers which will which the CNN is applying like filters to images and which will help the local feature extraction. These filters will detect what are the edges of the images, what are the edges of the objects, what are the possible tokens in a particular image, and what are the colors of the objects, what is the color of the background, etc. And you are trying to take out the complex features also, not only the basic features, you are also gaining the local features and complex features. After that, CNN is also having an activation function like ReLU, which is applied to introduce some sort of non-linearity which will help the network to learn more complex features. Pooling layers, these pooling layers like max pooling, which will try to sample the image by selecting maximum or average value in a region, which will try to make the model more efficient during the computations or calculations. Fully connected layers, after the convolutional layers, the high level features are passed through fully connected layers and typically leading to the final prediction of the images. Output, in case of image captioning, CNN generates a feature vector or a feature array which will be passed on to the RNN, wherein you are trying to generate the caption for the image. Then once the features are understood using CNN, we will pass it on to the NLP in order to generate the caption. So ResNet50 is a powerful CNN architecture which is often used for feature extraction. As I told, we are using the CNN. Under CNN, we use this model in order to get the feature extraction. So what are the key features of ResNet50? Residual connections, layer composition, it consists of approximately 50 layers, that is the reason the name ResNet50, with various blocks of CNNs, and pre-trained models, it is often pre-trained on the MS-COCO data set. And this ResNet50, what it will do, how do I generate the features? First, we are trying to extract the features. Once the features are extracted, what are we trying to do? We are giving it to LSTM or GRU, these are the NLP models which are trying to generate the caption. The sequence model is trained to output captions word by word. Word is taken as the token for us, conditioned on extracted image features. Fine tuning, it is based on, the fine tuning can be based on the specific task of image captioning. Again, we are using the same data set for image captioning. It involves adjusting the weights so that the network is better fitting in generating the captions which are not losing the contextual information. Then what is the attention mechanism? You keep adjusting the weights and try to understand the importance of various words in the generated caption. What is the example architecture for image captioning with ResNet50? First, we do pre-processing, then we do feature extraction, then we give it to LSTM or transformer model in order to generate a caption. Then we go for post-processing. What are we doing in the post-processing phase? The model has generated a sequence of words. Now you are trying to identify what could be the proper order so that you are trying to have a better understanding of the caption with grammatical correctness. So what exactly we learnt in this? Let us quickly conclude on this. We understood what is the data set which is helping in image caption generation, how the CNN is helping us to extract the features, and how ResNet is used in order to extract features till the caption generation. So with all these techniques, the models can automatically generate a contextually relevant caption for the image under question. Right? In the next session, we will be talking more on various applications of multimodal deep learning models. Thank you.